alkanes and alkenes and how we use these to maybe decide whether an unlabelled bottle was an alkane or an alkene. Found a lot of things in common, like they both were immiscible or insoluble in water and floated. We found that both decolorised bromine water, but in different ways, in different types of reactions. What we're going to look at today are just the reactions of the alkenes. Some of them we did yesterday, some of them we didn't do. Okay, because some of them require a bit more heat and so on. First one we're going to look at is addition. And the reason we're going to look at addition reactions is that they are a very good example of showing you a thing called Markov-Nikols's rule. It's a rule, which means it's not true all the time. Okay, rules now and then get broken. It's basically a set of ideas. Theories, on the other hand, or laws, are true. Okay? Well, there's so much evidence we can't disprove them. Now, what we did to start with today is we made a molecule of propene. Okay, so hopefully it looked something like that with the double bond. And we made a molecule of H2O. And we were asked to break the double bond and break apart the water and put them together in two different ways. And we found that one way was to make this molecule here, where it's got CH3 still in the same place. Whoopsie, let's turn that around. CH now had an H added to it. This one had an OH added to it here. That was one way that we could put it together. So I'll draw that one up now. So it had two H's on the middle carbon. It kept these two H's here, but it had the OH from there. So, sticking with my colour coding to make life a bit easier for us. An H got added there, and an OH got added here. The name of this is propan-1-ol or 1-propanol. Okay, anything with a carbon chain and just an OH as a functional group is called an alcohol. We're going to start talking about them and the chemicals we make from them very, very shortly. So it's in a nearby lesson. Okay, propan-1-ol. Then we looked at, was there another way to do this? So we broke off that one, we broke off that one, and we swapped them over. And we saw that a different molecule was made. That instead of having two hydrogens on here, only had one, but the OH was being added. So, there was another possible chemical. Oops. So the water bound a different way. H there, and OH there. If this one's called propan-1-ol, what do we think this one might be called? Propan-2-ol. Excellent. It's on the number 1, 2 carbon. Okay. So, my question is going to be, which one's correct? Which one of those is actually correct if I'm going to do an addition reaction with... It's actually dilute sulfuric acid, by the way. The water is dilute sulfuric acid. Because we need something to ionise the water. Which one?
Would it be the first one because it's the lowest number?
The first one because it's the lowest number. That is a good reason for that one. Could anyone give me a reason why it might not be the first one? Sorry? Oh, someone's already rated that. Okay, so actually the answer is yes, by the way. To which one is correct? The answer is yes, both. Both are correct. However, one of them is made in a much higher percentage. It's what we call the major product. So about 75% of the molecules are one of them, and about 25% of the molecules being made in the other one. So it makes a mixture of both. And then we have to find a way to separate those. Don't worry, that's university chemistry, not level 2. Okay? So they're both made, but we need to know, so therefore it's not or, it's and. Okay? So I put or there to mess you up. It's actually and. But we need to know which one is the major product, about 75% of it, 2/3 to 75%. And we use a rule called Markov-Nikod's rule. The rich get richer. And in this, the currency that we're talking about how rich we are, is the hydrogen atoms bound to the carbons. Okay? We ignore the CH3 because it's not involved in the reaction. Okay? The double bond is breaking, so it has to be one of these. These are the two carbons we care about. Only these two. So the poor one is the one that's got fewer hydrogens, because hydrogen is our currency. The rich one is the one with more hydrogens. So that means if hydrogen is my currency, the rich getting richer means that the carbon number one, this one over here, would gain more currency. So it would gain another what? Hydrogen. Cool. So knowing that the rich usually get richer, okay, not always, 25% of the time roughly, the poor get richer, so not often. Usually the rich get richer. Which one of these would be what we call our major product? Number two, propan-2-ol, because it had the hydrogen added with the other two, and this is why I used the colour coding to help you make that decision. So we call this one the major product. Now I'll grab one colour again. I'm going to use red, so you can help understand that it's where the hydrogen has gone. That helps us know this is the major product. And this one here is the minor product because it had the OH go there rather than the hydrogen. Again, I have to reinforce both are made. Okay, so it's not a case of one being made and not the other. They're both made, and then we'd have to separate them. And we could use some physical properties like maybe melting point or boiling point, density or something like that to do that. But again, how we separate them is university stuff. Okay. Addition isn't just with water. Addition can be with a whole lot of other molecules, and some of them Markov-Nikod's rule applies, and for some of them it doesn't. For example, we did an addition reaction yesterday where we added bromine water, Br2. Bromine, because it's the same atom, Markov-Nikod's rule doesn't apply. Okay, so we could have other things like bromine being added, and therefore any of the halogens, chlorine, iodine, that sort of thing. Another common one would be HBr or HCl. Do we think these ones could have Markov-Nikod's rule applied? And the answer is yes, well done, because they're different atoms or groups. Okay, so if you think of water as being HOH, that might help you understand why Markov-Nikod's rule can apply here. Just for your information, with these ones you also need something else present to help it go along. They don't just occur like the bromine one does. It doesn't just spontaneously happen. You've still got to have enough energy to break that bond. I'm just trying to think if there's any other examples we need to worry about. Water is our key one. These are our big three because they are often used in NCEA questions to show that you understand Markov-Nikod's rule. In an NCEA question, can you just say because the rich get richer?
No.
You can't, you have to qualify it. The carbon with more hydrogen atoms is more likely to form another CH bond. Okay? So the carbon with more hydrogen atoms is more likely to form another CH bond. If you can't remember that, just write the rich get richer and hope that they're being lenient that year. Okay? But you really should be qualifying it. The carbon with more hydrogens is more likely to form a CH bond. Again, the why that happens is university level mechanics of chemical reactions.